This is something that I think the old Earth creationists just will not recognize. Any time that you assign a calendar age to one of these radiocarbon ages, and it's not verified by independent eyewitness testimony, that's an interpretation of the data. It's an interpretation of the, now they say, no, it's not. But it is. It's an interpretation of the data. Maybe you think it's a reasonable interpretation of the data, but it's an interpretation. So these are not raw data.
Hello, everyone. Welcome to the Creation Podcast. I'm your host, Trey, and this is the third episode in a series called The Failures of Old Earth Creationism. Many Christians attempt to fit old Earth ideology into their beliefs, adopting uniformitarian or evolutionary ideas into their worldview. While this is often done in an effort to appeal to science, it can cause major logical, scientific, and theological issues. And as a reminder, this particular series was voted on by our members and patrons on YouTube and Patreon. So we're very grateful for that. If you would like to have a hand in shaping the direction of our podcast, you can become a member or a patron. Links are in the description below. There's lots of different perks, among which are the ability to vote on polls for topics for future episodes. So today, Lake Suigetsu is a large lake located near the coast of the Sea of Japan with a depth of about 34 meters at its center. Old Earth creationists claim that the sediments from the lakebed absolutely show that the Earth is at least 50,000 years old. What evidence are these scientists looking at that supposedly provide ironclad proof that Young Earth Creationist model is wrong? In today's episode, we'll explore the evidence in an effort to uncover the truth about Lake Suigetsu, dismantling the poor science that causes many well-meaning individuals down a path that only leads to error. And I have with me today ICR physicist, Dr. Jake Hebert. Thank you for being here, Dr. Hebert.
Thanks for having me.
Yes, for round 2, you were here in episode 1 for the episode about ice cores. We'll link to that right here. Fantastic episode that launched this series. So, but today we're talking about something entirely different. So, Varves. The majority, from my understanding of this whole situation, is the majority of this claim hinges on the existence of what are called Varves. So that sounds like something made up, honestly. I guess technically every word is made up in some way, shape, or form. But what is a Varve?
Well, okay, basically you will sometimes see these fine laminations in sediment, like a couplet. You might have a light band and a dark band, and those are sometimes assumed to be in a seasonal yearly cycle. And so creationists actually prefer the term rhythmites because we think that the word Varve is a little bit loaded because it kind of presupposes that each couplet is annual. And we don't think that's necessarily the case. But in this particular lake, you had a whole bunch of these Varves, rhythmites, whatever you want to call them, tens of thousands of them. And so the argument was, well, this shows that the Earth has to be very old.
Right. So why are these supposed rhythmites?
Mm-hmm.
Why do these rhythmites, why do these Varves, why are they supposed to be 1 year?
You know, I don't think there's necessarily a good reason to make that assumption.
Okay.
We know that they don't have to be annual. For instance, there's a lot of these rhythmites in the Green River Formation in Wyoming, and we've actually got some fossils here at ICR where you've got these fossils, fish that have been buried, and you can actually look around the edge of the fish and you can see dozens of these rhythmites. Mm-hmm. And so those cannot represent annual layers because the fish would decompose and be gone if those really were annual. Right. And that's going to be true even if you're in a lake that doesn't have oxygen. You know, it's an oxygen poor environment. It'll still decompose. So I think the claim that they have to be annual is probably more assumption than anything.
Okay. And so you mentioned another case of these rhythmites, of these Varves. My question is, like, are these a global phenomenon? And if so, why is there the focus on this particular lake?
Okay. Well, the rhythmites, you're all over the place.
Right.
You can some, even in that little mini canyon that was formed in Mount St. Helens, you've got rhythmites. The focus on this particular lake is because they think it's a particularly good place for this kind of study, low oxygen environment. And there's a few other places like that, which is kind of why they're focusing on this particular lake.
Okay.
Yeah.
From the top of my mind, they say the Earth is at least 50,000 years old. A point, 50,000 years old is still a very far cry from 4.6 billion, right?
Yes.
Yeah.
Admittedly, if it's ironclad evidence, that would be evidence beyond the biblical time scale.
Yeah, absolutely.
And I don't know if you want to go into this or not, but I've got a little background to kind of set this up.
Absolutely.
Okay. Well, basically what happened was when I first arrived at ICR, I kept hearing these stories that Young Earth Creationists were at these speaking events and that these old Earth Creationists were coming up to them and they were shoving this graph in their faces, demanded that they explain the good agreement between the radiocarbon ages and the counts for these Varve and tree ring ages. And, they never did it to me, but I think they might have even done that to Dr. Henry Morris, who was our CEO before Dr. Randy Galusa became president. Henry Morris III, not the original Henry Morris Jr. And so this graph was coming from a paper that was published by the BioLogos Foundation in 2010. And
so who is BioLogos?
BioLogos is an organization that really just urges Christians to embrace what they would call evolutionary creation, where they would basically say Christians should accept the evolutionary story, lock, stock, and barrel, and don't worry about any possible theological problems. In that sense, they are basically completely on board to the secular view. In fact, there are people at BioLogos, at least used to, I don't know if there are now, but there were people at BioLogos who would say that they didn't think Adam was a real person. That's the background. So they had a little paper that was published written by geologists Greg Davidson and Ken Wolgemuth that was purporting to show, using these Varves and tree rings and radiocarbon dates, that the Earth has to be at least 50,000 years old. Apparently, there was really good agreement between the different methods, and that was the argument. So in 2016, we decided, well, let's respond to this. And so I teamed up with Dr. Timothy Clary, who's a geologist here at ICR, as well as Dr. Andrew Snelling, a geologist at Answers in Genesis, and we wrote a lengthy rebuttal to that claim. And it was published in the Answers Research Journal. It's still online. You can read it for free if you want.
We'll link it.
Yeah, well, we'll give you the link. And then after that, we did a popular level summary in Acts and Facts. They kind of summarized the main points. That we're also going to link to that as well. And apparently we scored some points because their original paper was pretty much scrubbed from the internet. It was taken down from the BioLogos website. And not only that, at the time, a lot of old Earth creationists were just in love with this paper, and they were referencing it all over the place. You had all these old Earth blogs and websites that were kind of bragging about this paper. Now, the interesting thing is, today, the paper, you almost can't find the paper. You for sure can't find it on the BioLogos website. But if you look really hard, I think there's one overseas website where the paper is still up. And we're going to give the link for that.
Yeah.
If you want to download a copy of the paper, you may need to hurry because we don't know how long that link will still be valid.
Especially once this podcast comes out.
Yeah, especially since this podcast came out. So the thing is, we scored some points. They made some embarrassing blunders in that first paper. They mistook what we call a radiocarbon calibration curve, and for actual data, they treated it like actual data, which it's not. They failed to recognize some of the complexities of the what's going on. And in one case, they were sort of boasting about the good agreement between some of these, I believe it was tree ring and radiocarbon ages. But if you actually dig a little deeper and look into the paper they cite, you find out the agreements only after they made some adjustments to the data. And in fact, one of the papers they cite, it may have been that paper, they actually say point blank that they use, and I forget which way it went, either tree rings to correct radiocarbon dates or radiocarbon dates to correct tree ring chronology. So it was obvious that these were not true. In order for their argument to work, these have got to be truly independent age determinations. And as creationists, we would say they're not.
Yeah. Can't use one to calibrate the other.
Right. I mean, you can, but then you can't really turn around and say it's proof.
Right.
And so, interestingly enough, after that, I'm not 100% sure when the paper got taken down. By the way, we still have the links up on our ICR article, but if you click on the link and you go to the BioLogos website, it says, this page has evolved. It's a missing link, So you can't find it on the BioLogos website. So there's that. Now, it's interesting about I'm not sure of the exact timing on this, but about that time, BioLogos cleaned up their website. They had a number of articles that were scientifically suspect, and they took them down at that time. In fact, the president of BioLogos at the time sort of tacitly admitted that. And one of the ones that got a lot of attention that was taken down was by a biologist named Dennis Venema. And he was arguing the biology absolutely ruled out a literal Adam and Eve. And he got called out, not just by Young Earth Creationists. There were other people calling him out on that. And so they kind of took down this stuff. They didn't explicitly say why. They just kind of said, well, some of these arguments aren't good. We're looking for truth. We're trying to, fine.
The PR response.
Yeah, right? Yeah. So anyway, they did that. And so later they came out with another paper. They came out with a 2018 paper that, to be fair to them, I think avoided a lot of the mistakes they made in the first paper. And it's kind of serving as a replacement for their original paper. In a sense, it's the same argument, but minus the faux pas and expressed in a slightly different form.
Gotcha.
And so then I did a short little article on this on our website about it. And that's kind of where it stands today.
Okay.
Yeah.
No more rebuttals or cleaning of websites.
Right,
yeah.
Right.
Okay. So let's talk about these Varves that are supposedly showing how old this core is, right? So we talked about, you love cores, man. So we talked about ice cores.
Right.
Today we're talking about a core from the bed of Lake Suigetsu.
Yeah. Well, you've got these alternating bands. You've got some gray clay, and between the gray clay bands, you've got white diatoms, a kind of algae. And the thinking is, well, each of those bands, that pair represents a year. Okay, that's the thinking. And now the thing is, we know that even in today's environment, you can sometimes have multiple algal blooms in a year. Mm-hmm. So even here today, that's not an airtight argument. But we think, particularly during the Ice Age, conditions would have been very conducive to getting many of these blooms. Because these diatoms, they feed on silica. And silica is found in volcanic debris as well as dust. I think you can also find it in volcanic ash. But we think those things would have been going on during the Ice Age. A lot of it. We think there were very big dust storms, particularly at the end of the Ice Age. Mike Ord has written on this. By the way, the argument that they're making here is a new spin on an old argument. Okay, the Varve argument's been around for a long time, and creationists have responded to it. In fact, Mike Ord had written a response. It wasn't a response to this particular argument, but talking about Varves, it was published in a book. It was published in 2009, 1 year before the BioLogos article. I don't think he really went into the Lake Suigetsu too much. I think he mentioned it. He did mention it, but he didn't really elaborate a whole lot. But basically, the point was that you're going to have multiple layers form per year, especially during the Ice Age. And so we think that conditions during the Ice Age would have been ripe for having lots of these. And so we don't think you have to have eons for these to form.
Right.
Yeah.
And beyond that, it looks like there were just some errors. I have here that, that original research reported way less than 50,000 Varves.
Yeah, I think they originally even claimed there was like 100,000, and then it got down to 50,000. But if you read it carefully, there were lots of places where they had to interpolate, where there were gaps. And so they had to kind of fill in the gaps by making assumptions about what the sedimentation rates were. So when you got down to what they had actually counted, it was about 29,000 visible couplets.
Okay.
And now, of course, they would argue, well, that's still beyond the biblical timescale, but that's not that hard to explain, especially when you take these ice age conditions into account.
Right.
Now, I should point out, one of the things that we think that Doctors Wolgemuth and Davidson kind of failed to take into account is that this is a lot trickier than it seems. And, the Varves in that Japanese lake, what's interesting is when you have a Varve, they're counting what they think are layers. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. But if you look at the first Varve, they didn't assign it a count of 1. They assigned it an age of 8,000, I believe it was 830 years before present. Now, the question is, how do you count the 8,830 if you skip the first 8,829 integers? Good question. Okay, well, that right there is a clue that they're combining these data sets and they're making assumptions. It's not this trivial exercise that people make it out to be.
Yeah, it's not like it's a very clear 1 to 50,000.
No.
Okay.
And there's gaps.
Yeah.
There's gaps. Yeah, there's gaps, but they have to fill in.
Mm-hmm.
Yeah.
Okay. So 29,000, the original count. I just want to know, you mentioned that, that these don't have to represent specifically annual layers. But let's say we're being generous, we're being kind. Generally speaking, is it a reasonable assumption that they would be annual?
Well, they argue, they make an argument that they are, but I think it's an oversimplified argument. If you look at what they're claiming, it's sort of a hybrid Young Earth creation uniformitarian view. For one thing, they argue that if our view is correct, you ought to have a whole bunch of Varves that have the same apparent radiocarbon age. So where it's the curve is the amount of radiocarbons dropping down and then it levels off, and it drops and levels off.
Mm.
And I think that's probably too simplistic. For one thing, we think there were rapid variations in the Earth's magnetic field at that time. I'll give you an example. If you look at, they've actually taken cases where they've looked at foraminifera, where they've measured radiocarbon. And in one particular case that is in the work that in Dr. Baumgartner's work on the RAPE project on this. In fact, we'll give a link to that as well, where they measured the amount of radiocarbon on the inside and outside of the shell, and they differed by a factor of 2. Okay, but it looks like that critters, radiocarbon contents, it changed. There was a drastic change even within its lifetime.
Right.
So I think their argument that they make that these have to be can't be annual, I think, is too simplistic.
Okay, so when we were talking about ice cores 2 episodes ago, you had mentioned a lot of tephra, volcanic ash, volcanic debris. That was a good, indicator of certain things, and that actually pointed more towards a young Earth than the ages that they were assigning to those ice cores. Is there any of that going on here?
I don't know if there's anything in particular in the Lake Suigetsu Varves that necessarily does that. Here's basically the argument they're making. What they've done is they've taken multiple data sets. Okay, they have Varve data. I'm putting the word Varve in quotes. Okay, we're assuming these are annual.
Right.
From a lake in Minnesota. And then they had a tree ring chronology. And then they had the Varve data from this Japanese lake, and they combined them into a composite data set like this. And the argument was that the agreement between the radiocarbon and the calendar ages is too good in other words, the good agreement shows that the calendar ages are correct. The radiocarbon ages are correct. So there's kind of two easy ways to show that if you're using a graph, okay? One way is you could plot the amount of radiocarbon versus the calendar age. And basically, if the theory is correct, you would expect an exponential decay. If the typical uniformitarian thinking is correct on that. If all the assumptions are correct. Now, you could also, if you wanted to, you could take what we call the natural log of the amount of radiocarbon, and you could plot it versus the calendar age. And when you do that, you get a straight line with a negative slope. Okay, and so they were arguing in their first paper that graphs like this show that the agreement is very good, therefore we have to accept those ages. They make essentially the same argument in their 2018 paper, but they use the exponential curve. But in a sense, it's really the same argument.
Right.
Okay. If you had those two graphs are in some ways equivalent.
Different mathematics, right?
The problem that we creationists have, and we pointed this out in the paper that Dr. Snelling and Dr. Clary did with me, is that we don't think these age determinations are independent. Okay. There's a lot of times where and it's not as simple as everybody thinks. Like if you look at this, it looks like you've got 3 data sets.
Yeah.
Okay. Well, if you look at the tree ring chronology that they've constructed, and you got to understand the tree ring chronology they think it goes back 14,000 years. Okay. Now, very few of those, there are none that are individual tree ring chronologies or for a single tree that go back that far. Okay, the oldest trees on Earth might have 4,800 or 5,000 rings. Okay, and if you assume those are all annual, it's a little bit older than what we would, as creationists would accept. But what they normally do is they will take tree rings, and you'll have a tree ring pattern, and what they do is they look for another similar tree ring pattern in another tree, and what they do is they overlap them. So if you find a pattern of tree rings that looks similar in one tree to another tree, then they overlap them and they bridge them to extend the chronology. Okay, and so they keep doing that. And so if you look at the tree ring data that was used for that, you can see the list of all the data sets that were used, and I think it's probably more than 100.
Wow.
So it's a huge number of data sets that have been bridged together. And
each one of them, there's an interpretation involved.
Yes, and by the way, this is something that I think the old Earth creationists just will not recognize. Any time that you assign a calendar age to one of these radiocarbon ages, and it's not verified by independent eyewitness testimony, that's an interpretation of the data. It's an interpretation of the. Now they say no, it's not, but it is. It's an interpretation of the data. Maybe you think it's a reasonable interpretation of the data, but it's an interpretation. So these are not raw data. Okay. Once you start assigning calendar ages to them, that involves an interpretation, and they have to bridge them. They have to bridge these, and I will grant you that some of these correlations, I will admit, are convincing looking. Mm-hmm. Okay, I won't dispute that, but they're not independent. And for one thing, like you've got these gaps. Like I actually went and looked at one particular tree rings chronology, a German one, and I think there were 2 oak chronologies and 1 pine chronology, and you could see the radiocarbon ages and the calendar ages. And so I went ahead and plotted the calendar ages on the vertical axis and the radiocarbon ages on the horizontal axis. Okay, now even if you accept those radiocarbon ages as gospel, there's gaps. There's gaps. And so every time there's a gap, that means you have to assign an age. That's what we call a floating chronology. You got to, even if you can count 1, 2, 3, 4, 5, 6, 7, 8, you still got to assign that first number. And because they have to assign that first number, it gives them freedom to slide those data sets up and down on that vertical axis. And I'm not saying they're being dishonest, but when you're combining the data like that, you're going to do it in a way that looks reasonable
to you
within your uniformitarian framework.
Yeah.
Okay, so I don't think the apparent good agreement is, I can understand the point that they're making, but I don't think it's as simple as they think. And Davidson and Woolgamith, they act like there's really hardly any outliers. But there are, there are outliers in the radiocarbon dates. In fact, I was just reading a 2004 paper in the journal Radiocarbon where they had these radiocarbon ages, and there were two that were outliers that did not fit what they were expecting. They even had question marks next to them on their graph. And they said, we've got no explanation for why these differ. Now, they would argue, well, those were just a handful of examples. The thing is, when you look at stuff like this is even if they don't make the same mistake they did originally, and you were looking at real data and not just the calibration curve, that's after it's all been run through this interpretative process.
Right.
And I don't think you really can tell just by that how many outliers you've got. You really need to go back to the original papers. And I think if you do, now that would be a monumental undertaking. You're talking maybe hundreds, maybe thousands of papers you would have to go to. But I have a feeling there's a lot more outliers than everybody thinks. And I just think it's an oversimplification when they say, okay, well, this proves that this, because again, you're lining these data sets up. Okay, you're lining them up. A chain is only as strong as its weakest link. And every time you've got a gap, that gives you the freedom to move these data sets around. And not only that, but there's error. Even if you accept the uniformitarian assumptions, there's error. There's a range in the radiocarbon ages. So you've got a little freedom to slide them this way too. So I just don't think it's the compelling argument that they think it is.
This actually reminds me a little bit of our first episode together that we did in this series, where all it takes is one number being wrong to throw off everything else. And this is another case of that.
Yes, it is. Yes.
Wow.
Yeah.
Okay. So not only that, from my understanding, when you even look at these Varves, they're hard to count too, right? And I have that. The researchers even mentioned that maybe as many as half of the Varves could not be clearly distinguished.
Yeah, so they had to interpolate.
Yeah.
They had to interpolate. Now, the ones that you could distinguish, I would imagine, were fairly clear, but you've got to interpolate. You've got to make assumptions about sedimentation rates to try to bridge those gaps. And so it's not like, oh, we actually saw 100,000 or even 50,000 couplets in that lake. Okay, we didn't. But that's the way they're interpreting it.
Right.
Yeah.
Okay, so then how would we then, if we're left with 25,000-ish Varves, how does this fit in with a young Earth biblical narrative?
Okay, well, again, we think the key to explaining this is probably the post-flood ice age, because you had all these volcanic eruptions during the ice age. You had explosive volcanic eruptions, and you had heavy dust storms at the end. And Mike Ward's written about that. That's a part of our creation model. And so you've got silica. Those diatoms feed on silica, and so you can simply get more than one bloom per year, possibly many blooms. I mean, if you've got hundreds of these volcanic eruptions going off in hundreds of years, and you've got these big, intense dust storms toward the end of the ice age, basically, we just don't think they're annual. We think these are multiple blooms that are occurring per year.
Okay, and do we have evidence that it does happen currently?
Well, we know it can happen annually. Yes. Now, you would say, well, maybe it's just a few per year, but yeah, it can happen annually.
Okay.
Yeah, even today.
Okay.
Yes.
Awesome. All right. So then we have the heat model again. It's interesting how both your episodes kind of fall into the same category there. It's almost like you're a physicist. So the heat model kind of accurately has an explanation for this that does not involve this 50,000 year time scale and also doesn't involve the guesswork, right?
Right.
Okay.
Yeah.
All right. So radiocarbon is also that plays a big part in this, and we've talked about radiocarbon a little bit already when it comes to the Varve formation, etc. How does that connect with like the radiocarbon in old fossils?
Okay. Well, you find radiocarbon in fossils that are even supposedly by their reckoning are millions of years old.
Right.
You shouldn't be able to find radiocarbon in things like that old. If it's really, even if it's say 75,000 years old, you're pushing it. And at ICR, we often just round up and say, if something's more than 100,000 years old, you should not be able to detect radiocarbon in it. And yet, we've got all these examples, not just in the creation literature, but in the mainstream secular literature, where you've got measurable amounts of radiocarbon in these fossils that should be radiocarbon dead, it shouldn't be there. And this is a major contradiction with the millions of years worldview, because this is something I don't think they've got a good explanation for. Now, Wolgemuth and Davidson take a stab at addressing it in their latest paper, but I don't think they convincingly answer the objection.
Right. So radiocarbon, it decays over time, correct? Yeah.
Yeah. So basically, radiocarbon is a particular radioisotope dating method. And what happens is living things ingest carbon. Okay. They take carbon into their bodies. And in today's world, in the biosphere, you've got about 1 out of every trillion carbon atoms is a radiocarbon atom. Okay, it's a radioactive isotope or variety of carbon. Now, the radiocarbon will spontaneously transform into nitrogen. You can't predict exactly when any particular atom will do that, but if you have a whole bunch of them, you know that it will take 5,730 years or half of them to turn into nitrogen. Okay, that's the half-life. Okay, so because of that, they think it can be used as a clock, because once an organism dies, as long as you're replenishing the carbon in your body, the ratio of carbon-14 to total carbon in your body ought to stay the same. And sometimes we abbreviate that as percent modern carbon. Like the ratio today, we'd call that 100% modern carbon. 1 radiocarbon atom per trillion carbon atoms. But once you die, you're no longer replenishing the carbon. So as those carbon atoms turn back into nitrogen, that ratio gets smaller and smaller and smaller. It becomes a smaller and smaller percentage of this modern carbon ratio. And so the thinking is you can use that as a clock, and you can use it to date things. And interestingly, people mistakenly think radiocarbon proves millions of years. It doesn't, okay? Because even if you grant the usual uniformitarian assumptions, you can only use it to date things maybe 50,000 years old or so. It doesn't prove millions of years. Now, they would say, well, it still proves the Earth is older than 6,000 years. But actually, it's quite easy for biblical creationists to explain why those ages are inflated, why the radiocarbon ages are inflated. Do you want to get into that?
I do.
Okay, all right. Okay, so basically the problem that the reason these ages are inflated, like for instance, if you look at fossils from the flood, we think they're roughly 4,500 years old.
Right.
Okay, but instead of giving it an age of 4,500 years, you might get an apparent radiocarbon age of 45,000 or 50,000 years or something in that ballpark. Why is that? Well, it's because the uniformitarians are assuming that the only reason that radiocarbon to total carbon ratio would drop is because of radioactive decay. And what they're failing to take into account is that in the pre-flood world, there was a huge amount of carbon, okay? Much more carbon in the biosphere than there is today. Probably at least 100 times more.
Wow, okay.
So what that means, I mean, we don't know exactly how much radiocarbon was in the pre-flood world, but let's just assume it's the same as today, the same amount. And let's just, one estimate I've seen is that the total carbon could have been 300 to 700 times greater than it is now. Let's just split the difference and say 500 times greater.
It's an easier number to work with.
So if it's 500 times greater in the pre-flood world, that means that ratio isn't going to be 100% modern carbon. It's going to be 0.2% modern carbon. You divide 100 by 500, you get 0.2. So let's do a little thought experiments. Let's suppose you've got a time machine and you can travel back to the flood, the day of the flood, and you see an animal that falls over and dies, and you brought your radiocarbon dating equipment with you. You got a lot of lab equipment. You start taking samples. You get some carbon. You isolate it. You measure the radiocarbon, and if you use the standard assumptions that they make when doing these dates, you're not going to get an age of 0.
Yeah,
you're going to get an age of almost 52,000 years for an animal that just died. And so what we're saying is uniformitarians. Again, this is where that assumption of uniformitarianism trips you up. They're assuming that's not the case. They're assuming that ratio has always been pretty much what it is now. They do allow for minor fluctuations, but they think it's been pretty much what it is now for tens of thousands of years. And if that assumption is wrong, you automatically get these inflated age estimates. So creationists are in no way intimidated by these radiocarbon ages, okay? Explaining why they're inflated is almost trivial. It's not a big deal.
I can just hear the evolutionists now. They're thinking, oh, okay, so you're saying that all of the fossils, at least the vast majority of them, come from the flood. And so at that point, they would supposedly have at least a similar radiocarbon age, but they don't. There's a scatter.
Right.
Can you explain that?
In principle, you would think they all had to have the same apparent radiocarbon age.
Right.
But there is a scatter. It's not exactly the same. What creationists think is we believe there was accelerated nuclear decay during the Genesis flood, where the heavier nuclear isotopes were decaying a lot faster.
Okay.
We don't think radiocarbon was changed very much. We think it was mainly the heavy nuclei that were doing this. But we think there was probably about 500 million years worth of accelerated decay during the flood. Now, when you have that accelerated decay, okay, you've got uranium in the Earth's crust. When uranium turns into lead, it's a long process, but they shoot out these little atomic bullets, I guess they're like helium nuclei. They call them alpha particles. Okay, they're like little bullets and they shoot out. And these bullets, if you will, these little bullets can interact with some of these lighter elements like aluminum, magnesium, oxygen, and silicon. And as a result of that interaction, you get these neutrons. Neutrons are produced. Well, the neutrons can interact with the nitrogen and produce carbon-14, which is very similar. That's what happens up in the atmosphere. Neutrons are interacting with nitrogen. They're turning into carbon-14. And we have that in the atmosphere, but we're thinking that during the flood, if you had accelerated nuclear decay, you've got nitrogen that's being turned into carbon-14. So let's suppose you've got some fossil that is next to a hunk of uranium, okay? What's going to happen is some of that nitrogen is going to get turned into carbon-14, probably quite a bit of it. It's 500 million years worth of decay. And so what happens is, depending on how close a fossil organism was to that ore, you're going to get scatter. Okay, so it's not going to be exactly the same
because there's other things going on other than just the death of the animal itself.
Right. So it's that is why we think there tends to be this scatter in the amount of radiocarbon, and you don't get exactly the same age for all the flood deposits.
Okay. Wow.
Or flood fossils.
So how then do old Earth creationists or uniformitarians, how do they explain the radiocarbon in these fossils?
Well, a lot of times they say it's contamination from the measuring process, when they clean it. But I don't think that explanation works. If you read Dr. John Baumgartner's 2005 paper that was published as part of ICR's research project, he gives examples where the experts say we can't blame this on contamination. It's not contamination due to the instrumentation. They will say, oh, well, maybe it was in situ contamination, which means, but if it's in situ, remember what does in situ mean? It means it's really there.
It's just there.
Out when it was out in the field. Is it really contamination? And Wohlgemuth and Davidson they say, well, the amount is typically close to what you would see from contamination. I don't think that's quite right. The numbers I've seen are considerably higher than the number they usually subtract off for what they think is instrumentation error.
Right.
And so, they would argue, well, it's all kind of on the borderline anyway, but the values you typically get are maybe 0.1 to 0.5% modern carbon, which I think is considerably higher than what they normally subtract off to take that into account. But this is in the mainstream literature. I mean, they have known for a long time that you've got radiocarbon in specimens. They're too old. It's not supposed to be there.
Mm-hmm.
Another thing is, I can tell you just from my own personal research, I don't think the experts completely trust radiocarbon dating. And I'll give you a good example from my own research.
They won't admit it, right?
Right. Sometimes what's instructive is not just when they use radiocarbon dating, but when they don't use it. Okay, if you remember that first podcast we did about the Milankovitch Ice Age theory and the evidence for that theory, there were two sediment cores that they used to supposedly confirm this theory. Now, what was weird, in one of the cores, they had a radiocarbon date. The second core, which was the longer core, they said, we can't use the top third of the data in this core because it's too old. We don't know how old it is. It might be 60,000 years old. And so they just excluded it. In fact, what's bizarre, they didn't even plot the data on their graph. I don't know how they got away with that. There's this big gap on their chart. Here's why that's a problem. Okay, well, I have a big problem with that argument. But when they excluded that third of the data, it made it much easier for them to get results that confirm the theory. Okay, it's a lot easier to do it. And I'm convinced that had they included that upper third of data, they would have gotten results that did not agree at all with the Milankovitch theory. Because I went back and redid it. Somebody actually went back and published those values, the chemical wiggle values, and you can get the whole data. And so I did that. I did that. I used their methodology, and later on they said the top of that core was 12,000 years old. And so when I did it, and you do the analysis, the results are crummy. If you use the same age control points they used in that analysis, those results don't even come close to the Milankovitch theory. Okay, it's a complete mess up. Okay, but here's the problem I have. If you really trust radiocarbon dating, why didn't they use radiocarbon dating to test the top of that second core? Okay, this is a potentially falsifiable hypothesis, right? You're saying the top of the core is too old. We can't date it. Well, why don't you try to date it with radiocarbon dating? And if you do, one of two things is going to happen. You're either going to get a young age, which means you can use it. You ought to include it in your analysis, or you're going to get an age that's too old. Okay, or you won't be able to get what you think is a good radiocarbon date.
Right, what they're expecting, right?
Right. But they didn't do that. Yeah. And it was striking to me that they did have a radiocarbon date from the first core. And by the way, I think that radiocarbon date was totally meaningless. It had almost no bearing on the results. I don't even know why they included it. But here, where you had a serious question about whether you ought to be including a third of the data, you would think it would be a no-brainer to do a radiocarbon test. They didn't do it. So what that tells me is these guys don't trust radiocarbon dating as much as people think they do. I think, and look, I'm not a mind reader, but my suspicion is they didn't want to do the radiocarbon test because they were afraid it would give them an answer they didn't want.
Yeah, they're only going to do it when they're certain that it's going to confirm what they already believe.
See, sometimes this is something that's easy to overlook. Mm-hmm. It's not just the tests that they do that tell you something. It's the tests that they don't do. Mm-hmm. And so when they refrain from doing a test that you would think would be a no-brainer, that's telling you something. Mm. Yeah.
Look a little deeper. Yeah.
Yeah. So, Wilgemith and Davidson, we can completely trust these radiocarbon dates. I don't think so. I don't think we can. And now, one of the problems I guess I have with the argument, and I can understand the argument they're making, but again, to really be sure how many outliers there are, you got to go back to the original data. And like I said before, you're looking at maybe hundreds, maybe thousands of papers that you would have to comb through and figure out and look at the original stuff before it's been processed through this uniformitarian framework. And again, I'm not saying they're being deliberately dishonest, but again, if you're a uniformitarian, you're going to interpret the data in a way that makes sense to you, that seems to be reasonable. So I just don't think it's the slam dunk argument they think it is.
Absolutely. Radiocarbon dating or Lake Suigetsu's, Varves, regardless, it shows that there's just assumption upon assumption upon assumption and faulty science.
Yeah. By the way, the argument that Wolgemuth and Davidson made about the amount of radiocarbon being very small, it is true. Most of the measured values in the fossil record are about 0.1 to 0.5% modern carbon. But Andrew Snelling, there was a case where Andrew Snelling looked at fossilized wood from Jurassic strata, where the percent modern carbon that was measured was 7.5, I believe, which is a lot. I mean, I think that translates roughly into an age of 20,000 years for stuff that's supposed to be hundreds of millions of years old.
Right.
So most of them are kind of narrow range, but there's some that are considerably higher than that. So you could argue those are outliers, but they do happen. Yeah. They do happen.
An outlier is still an outlier.
It's an outlier, yeah.
Absolutely. Well, you are very passionate about these topics, and it's fun to see you dig in and we just want the truth here. We don't want, because people believe these things. Right. People who aren't scientists will read the paper, or even worse, they'll just read the headline or the title and just be like, yeah, the scientists said it, so it's true. And that's a problem, because when you dig deeper, when you do the real science or even just the real math, and you realize that, hey, this doesn't align. Right. So do you have any closing thoughts or anything you want to say here at the end?
Well, let's see. Just because somebody shoves a graph in your face doesn't mean you have to accept the argument, especially if you don't know where the graph came from.
Right.
And it seems almost like a kind of proof by intimidation, where old Earth creationists come up to you, they throw a graph in your face, and you're supposed to just concede their point because of a graph. Well, you got to look at where the graph came from. You got to look at what assumptions went into it.
Yeah.
And so,
don't be intimidated.
Don't be intimidated. Yes.
Yes. Awesome. Well, thank you so much, Dr. Heber. It's been a blast, and we won't see you again on this series, but thank you for lending 2 incredible episodes of your time and expertise. So,
okay. Thank you.
Thank you.
All right.
And thank you to all of our listeners and viewers for being here. I'd like to remind you that this series of episodes was voted on by our members and patrons. So if you are so inclined, feel free to become a member or patron. There are links in the description. You can help vote on topics for future series. You can get access to podcasts ahead of time or other special videos. And that would really help us out on this channel. Make sure to like, subscribe, share with your friends. We do want to get the truth out. Again, our purpose here is not to bash or hate on anyone. Our purpose here is to say, hey, when you look behind the curtain, when you look at the science, there are problems with some of these things that people are saying. And we want to make sure that people are not intimidated, that believers are not intimidated by what they assume or what they are told to believe. So make sure that you do your research or listen to people who are actually doing their research instead of just believing the headlines that you read on some of these things. So we'll see you next time on the Creation Podcast. We want to say a huge thank you to our members and patrons. If you'd like to see your name here and unlock perks like early access to our podcasts, members-only polls and live streams, behind-the-scenes footage, or exclusive video content, links are in the description below.